Hello and welcome to my YouTube channel Coders Tech. This video deals with Q. So guys, before starting, if you have not subscribed to my channel, subscribe it for more such useful videos. So what is Q? A queue is a linear data structure which follows first in first out principle, in which insertion is performed in the rear end and the deletion is performed at the front end. So the type of queue are, first one is linear queue, second is circular queue, and third one is called double-ended queue. So the basic operation which are performed on queue are: queue operation may involve initializing or defining the queue, utilizing it, and then completely erasing it from the memory. So the basic operation associated with queue are ENQUEUE, which adds an item to the queue, and DEQUEUE, which removes an item from the queue. So guys, queue can be implemented by two ways: array implementation, and second one is linked list implementation. So this video deals with array implementation. So now let's see the logical solution with explanation and the array based queue code. Now guys, we will be seeing the array based implementation of queue. So before going to that, you should know that in array based implementation of queue, you have two datas which are integers specially. So they point to -1. So those data are front, which is equal to rear, and they both point to -1 initially. So now we will be going for ENQUEUE operation. So now we will be going for ENQUEUE operation. So as I told you earlier, in your ENQUEUE operation, you can enter an element in your queue. So this is your array based implementation of queue. So your first number, your data type, that is front, let front be represented as F and the rear be represented as R, will point to -1. So it points to -1 now, and it is somewhere here. It is outside your array. Now when I enter the very first element in my array, let it be 10, then your front and rear both becomes 0, and both of them points to this location. So after doing this, you should know that your front will not change if you keep on adding your values in your array. So if I now enter my value at the first position, that is after the rear position, at the rear position at the first in this index number, first in this array, so let it be 20. Now if I enter 20 here, your front will point to 0, but your rear will become 1, that is, it is incremented by 1. So now they point here, your rear point here, but your front points to the front position. So as I told you earlier in the introduction, that queue follows first in first out principle. So your front focuses 10 because it's the first element. Will make it more clear in your DEQUEUE operation. So now your front is pointing to 10 and your rear is pointing to 20. Now let us keep on adding elements in your queue. So now it is 30. Now let it be 40. Let this be 50. This one be 60. And this one be 70. Now after you do this, your array is full. That is, your queue gets full. Now you can't add. At the end of this operation, you will come to know that your front is equal to 0 and your rear is equal to the sixth index number, that is size minus 1, sixth index number, and both of this rear points to 70 and your front still points to 10. So this is your NQ operation. So if you want to enter more elements, you cannot enter any more elements because your array is full, your queue is full. So this is all about NQ. So what we have seen here is, first your front and rear will be -1, then your front and rear will become 0, and then after that the front will not change in your inserting when you insert an element in your queue, and your rear changes. So first rear will become 1, 2, 3 up to the size -1, and after that if you add any other element, you should write a code in such a way that it show you a message which is overflow. That is, you are not able to insert any of your element in your queue anymore. So this was about your NQ operation. So now we will see about your DQ operation. So guys, now we will be seeing about DQ operation. So what is DQ? As I told you earlier also, your DQ operation is an operation in which you delete an element from the front position from your queue. So now, as usual, your front will be equal to rear equal to -1 at the initial position at the starting of your queue when you have no element in your queue. So in your DQ operation, your front and my rear is equal to your front is equal to rear equal to -1 initial. Now after that, let me add some random number here because I can't tell you DQ operation without an element in your array. So now here let it be the same: 10, 20, 30, 40, 50, 60 and 70. So now after that, I have told you in your NQ operation that your front points to 0 and your rear points to 6 index number. Now what if, as I told you, it's first in first out principle. So 10 came to this queue first, so 10 should be deleted first. So this element will get deleted first. So after this element get deleted, the 0th index number is empty. So this is where your front was pointing first. So now what you are supposed to do is to increase the index number of front by 1, so it points to this index number, because you want to delete your first element, which is 10. So for doing that, you should just increase your front by front plus 1. So now it points to the first index number here. So now after that, your rear remains same. Your rear is 6. Nothing will going to change in your rear. Now after this, I have to delete this element. So let me delete this element. So after deleting this element, you will find that f will increase by 1. So your f increases by 1. So it's pointing here, and these two are basically empty. There's nothing in this because they got deleted. Now after going to 2, you want to delete this. Now after deleting here, now your f will point to your 3. So let us delete till, let this be deleted, this be deleted, this is deleted. So now your front will be at 5 and your rear is at the same location, which is 6. So after this, what happens is, your front is at 60. Now in the queue we have some space, we have a limitation called space which is not utilized. So after this you will know that this and all are empty, there is nothing in this. So this space is not utilized and you cannot even add more element in your rear end because it's already filled. Even though your queue has some spaces left, but because your front points to the fifth location, in this case that is the second last position, and your rear end points to the last position, all this element here, all this space here are empty, and this is the biggest limitation of your queue. Even though you have space, even though your array is, you have space in your array, you are unable to add any of your data in the remaining part of your queue even you have space. So this is the biggest limitation. So what if, now you should keep in mind, what if full of your list is empty and you decide to delete an element? So for that case you should give a code in such a way that it give you a message which states that your front is equal to -1, and which will give you an output message which will say underflow. So it will say underflow, which means there is no element in your queue and you cannot delete any element from your queue. So guys, that is all about your enqueue and dequeue operation. I hope it is clear. Now after this we'll go for the code. Friends, one thing you should keep in mind, that is, it's a kind of note. So please make a note of this. In your dequeue operation, what if your front and rear become equal? What if your front and rear is equal? That is, your front is equal to rear. This is possible in two cases. First, let me put some element here. Let me put 10 for the first case. It is possible here. In this case, your front and rear both will point to 10. That is, both will be 0. And what if you delete this element? When you delete this element, you should keep in mind that you make your front equal to rear equal to -1 again. Front equal to rear equal to -1 again. So if you do that, you can reuse your queue. Suppose you have an element here, like let it be 10, 20 and 30. So after that you delete your 10. So your rear will be here. So your rear will be here, which will be equal to 2, but your front will be equal to 0. So suppose I delete this element and I delete this element. So what happens is, now my front and rear both will be at 30. So both will be at 30. Now front will also be 2 because I have deleted 10, 20, now it's there. So in this case, after doing this, suppose you are deleting the element 30. So after deleting your element 30, there is nothing in this queue. There is nothing in this queue. I have deleted 10, 20 earlier and now I am deleting this 30. So after which there will be no element left in your queue. So all your queue is empty. So don't forget to make your front and rear position as -1 again, because if you don't do this, your queue cannot be reused and there will be memory wastage. So please do this in your program wherever you write. So guys, that's it for your theory, and now we'll go for the code. Now friends, this is the code for your queue operation. So here I have my queue, that is my array here, which has 10 elements. The size is 10. The front and the rear, which is pointing to -1 initially, and both of them, all the three of them are global declaration. So all the three are global declaration. Yeah. So now after that, I have an I have a function called ENQUEUE. So in which I take an integer number from the user because my queue array is integer. So enter a number to insert. This is the message for the user. So the user enters a message here, enter the data here, sorry. Then I check if my queue is filled, that is the maximum size here is 9. So if my rear is pointing at the last value, I can't add any more value into my queue, and hence a message called overflow. I have told about this in my enqueue operation. Then after that, what if there is space in my queue? So it is like if I am entering for the first time in my first element in the queue, then I will make both front and rear as 0, and I'll put X at the rear position, that is at the 0th location. So this is done now. Now if it both are not the case, then the third case can be this one. Then I will increase my rear to rear plus 1, and I'll enter my value to the rear position. Like from if my rear is pointing at 2 and I want to enter an element, so I will make my rear to point at 3 and enter the element at the third location. So this is all about enqueue operation, that is inserting an element in the queue which take place only at the rear end, and hence I have used only rear in this. So you can see I have used only rear in my program. So now after this, let's go and see the DEQUEue operation. So in your DEQUEue operation, I have made an integer called x. So what is the purpose of x? We'll see at the bottom of this function. Now first of all, if f equal -1, what if there is no element in my queue? So my queue is empty, and hence I give a message called underflow. So after giving this message, if my queue is empty, then there is no need to check this else condition. But if this condition is not true, the control go to else statement. So in else statement, I am using my x variable here. I am storing the x, that is I am storing my front element which I am going to delete in this x. So it gets stored. Then after that, I display the deleted item to my user. So it is shown here. Then after that, I have this statement. So friend, what if you enter first element and delete it? So first if you enter your element, your front will be equal to rear, which will be equal to 0, and you delete it. So your front and rear both should become -1, because in this case, if you have to make your list is empty, full empty, so both of them point to the initial position. Hence they point to the initial position here, front equal to rear equal to -1. As soon as I enter one element and delete it. So this is what happens. But after that, if we don't have both these cases, then we go for this else statement. So in this else statement, I will increase my front by front equal to f plus 1. Like after deleting the element in the 0th location, now my front points to the element in the first location. Then after that, let's go and see the display function. In my display function, I have an integer I which will be used in the for loop. Then I am checking if my rear is equal -1. This shows that my queue is empty. There is no element in the queue. Hence I display a message here to help the user. Then after that, if this does not satisfy, then after that I give a else statement. So in the else statement, I run my for loop from I equal to front and I less than equal rear. I equal to front because your element can only be present from your front location till your end location. Hence from front to the rear, and I print all the elements here. So after this, let's go and see the void main, that is int main. So now my integer a is 0 and I have an integer n here. So I have an integer n there. Now I use a do while loop here because it will display the message, that is its body message 1 without checking the condition, and then in that I am giving insert 1 for inserting data in queue, that is for enqueue, 2 for dequeue, and the third one is for displaying. So then I input the number, then I use the switch case in which if n is 1 it will be enqueue function will be called, if case 2 dequeue function will be called, and if it is case 3 display function will be called, and if they enter any other number except this 3 it will post invalid number. Now after that I have given a printf statement in which it states that do you want to continue, press 0 for yes and 1 for no. So this do while loop will work until my a is equal 0. So now let's run and see what's the output of this one. So now here is the output box. So here first one, enter 1 for inserting, 2 for deleting, and 3 for display. So now first let us give 2 and see. So now you can see that it gives you a underflow message because you cannot delete from an empty list. Now I give 0 here. So after giving 0, it again states that enter 1 for inserting. Now let's give display and see. So I give 3 here and see. So now it shows that your element, there is no element present in your queue, hence nothing is displayed. Now let us give 0 and start inserting some data in my list. So I'll give 1, then I'll enter 5, now again I'll give 1 and enter 8, and now again I'll give 1 and insert a data, let it be 45 this time. Then I will call the display function. So I call the display function, and you can see I entered 5 first, it's at the 0th position, 8, and then 45. Now I will delete element. So now I'll enter 2, and then the deleted item is 5. You can see that the deleted item is 5 here. So after that I give an element call, then now I'll give 0, and then I'll call my display function. So I'll give 3. So you can see the first element which came was here. So the first element which came was here, 5, and there is no 5 here. We have only 85, 8 and 45, and 8 and 45 here. So you can see the first one which came deleted first. So this is your queue operation. So guys, I think I made it clear. Guys, mail at coderstate@gmail.com for any queries. Thank you for watching. Like and share my video. Subscribe to my channel and keep coding. Thank you.